Explain a complicated multi-step procedure for answering a question such as this. What is the maximum value of P given that P equals x plus y? Well, as expressed like that, the answer is that it could be anything. Like if x was 1 million and y was 2 million, P would be 3 million. If x was 4 billion and y was 10 billion, then P would be 14 billion. So the answer to this question as it's currently stated is that there is no maximum because x and y can be as large as you like. But if I add some constraints, so I tell you that x has to be at least 0, y has to be at least 0, and I know this is sloppy, by the comma I mean and. Well, that doesn't make much difference, just insisting that they're not negative numbers. But let's say I tell you also that the sum of x plus 2y has to be less than, say, 10. Well, then what's the maximum? Okay, because now I can't just say x is 1 billion and y is 7 billion, because 1 billion plus 2 times 7 billion is certainly not less than 10. So these constraints mean that the question is now answerable. So how do you answer it? Well, here's the multi-step procedure. First, you lay down a region showing all the points that satisfy those constraints. So here is the region. And I'm just going to quickly graph these by imagining that these three symbols are zeros. So x equals 0 is this line. Y equals 0 is this line. X plus 2y equals 10. I'm going to do that with a quick table. If x is 0, then y equals 5. And if y equals 0, then x equals 10. So here is the region. I think I want that side of the line because if you imagine x being 0 and y being 0, then x plus 2 times 0 is certainly less than 10. So this point, 0, 0 counts. So the region I want is this. What I've done now is I've shaded all the points that satisfy the condition. And so what we want to do is pick the points that make this as high as possible. And the way you do that is by doing a fake little line. What you do is you just take a concrete value of P. So this is like trial and improvement. A nice large concrete value of P. So for example, x plus y equals 12. So this is the same as that. It's just that P has now become 12. And then you graph this. I'm just going to do this quickly. And now what you do is you get your ruler. Oh, wait on, other side. And you just move it towards the region until you can first see your ruler grazing the shading that you've done. There it is there. It was that point there. That was when my ruler, running parallel to my fake line, first touched the shaded point. Now this is what I informally call the graze point, because if you do it in this position, then this line would just graze the region. Okay, so that's the first. So that's the second element of the procedure. Sorry, third. First is to lay down a region based on the constraint. Second is to graph a line of your choice, which came from choosing a value for P. The third is then to move the line gradually, always parallel to the constructed line until you get a graze point. And then the fourth point of the procedure is to find out the coordinates of that graze point, which can come from simultaneous equations, but in our case is obviously 10, 0. And now the sixth and final step is to take those coordinates and put it back in the original thing. So P equals x plus y is maximized when P equals 10 plus y, 10 plus 0 equals 10. Now, that is the basic procedure. I'm going to not do another example in this video, but what I'm going to do is I'm going to do a video solution of all 9 examples in the exercise, which you can find in a separate video, and then you'll get the hang of it.